All right, so this is my first time using this, so bear with me. So we're gonna be looking at module 3. All right, so let's go. First off, I use SPSS, and I admit it's pretty shitty as far as like the nice graphs that ours produces, but it compensated by giving me some nice tables, so I'll present the same information. So MRC, multiple regression and correlation, it's a measure of association. We get a nice little standard formula, y equals b naught plus bx plus e, which is the residual. So it gives us a line of best fit based on the y-intercept and then like whatever variables you want to add and their slopes. And what it is the least or small squared residual. So, making sure that each residual is close to that line as possible. It tells us how multiple independent variables impact the outcome variables. And for this one, it was really important to note that, error is attributed to the model. So this is our 3 a.m. at the bar. So for my model, I use Y1, X1 through 3. So we get some descriptive statistics right here. But we really want to look at these B values because, we have right here the constant is the y-intercept, and then these are the slopes or the weights for our independent variables. And so we look at the standard error. We want to, minimize that because that higher standard error means that, like our best guess isn't that good, which is we don't ever want that. So these T values right here. So basically the null hypothesis for this test is that these betas are not different. Null is that beta equals 0. So these T's and these significant values taken together say that I fail to reject the null hypothesis because there are no significant findings. So therefore, none of the betas are significantly different than 0, which, like in a perfect world, I would like to have a cooler relationship, but it didn't work out. So now I'm going to talk about the assumptions that we need to meet. Also, it is, oh, never mind. Okay, assumption 1, dependent variable is continuous, and there are at least 2 independent variables. We have 3. Okay, so independence of residuals is, so for SPSS purposes, I was given the Durbin-Watson measure, and a value of 2 usually indicates that the residuals are independent, so I don't have reason to believe I would violate that assumption. Linear relationship residuals between the residuals and dependent variables. So basically what this one was looking at is variance around the regression is the same for the all predictive variables. Based on this model, I would be cautious of the high numbers right here or at these points because it seems like that's a little pattern right there, which doesn't indicate independence. So to further look at that, we have the partial regressions for each independent variable. So, in various plots, like there are problematic data that go into it, but once again, SPSS didn't give me one complete graph like it does in ours. So I may have violated that assumption for homoscedasticity of the residuals. God damn it.